Can you see the live has started? तो मेरा आवाज आता है कि नहीं वो भी सबसे बड़ा प्रश्न उधर है. आ रहा है आवाज आ रहा है. साउंड है. मैं भी ज्वाइन कर रहा हूँ. उसको शेयर कर देते हैं ना. बस शेयर करेगा रे. So we are now looking at oscillation questions. So some of the questions we will take: an object undergoing SHM with a period of 0.3 second. So the time period we know is 3 seconds, 0.3 seconds, sorry, up to 3 decimal places. And amplitude is 6.00 centimeter. So amplitude is at t is equal to 0, the object is at rest at x is equal to 6 centimeter. So t is equal to 0, x is equal to 6 centimeter. Calculate the time it takes the object to go from x is equal to 6 to x is equal to minus 1.5. So x is equal to 6 to x is equal to minus 1.5. How much is time, or delta t rather? That is your question. Let me change the screen to board. Let us see if the board is visible. It's visible up till here and up till here. Fine. So that is our problem. Okay. Time period, amplitude from t is equal to 0 to t is equal to 6. At t is equal to 0. So basically the issue is you have an particle here. Say that this is origin. This is amplitude is 6 and particle is at 6. Means the particle is at the right extreme. If I take this as y-axis and take this as x-axis, particle यहाँ पर है, x is equal to 6, which is also amplitude. Correct? Particle को आना कहाँ पे है? Particle को आना है minus 1.5. Minus 1.5 will be here. You can guess here. 6 का आधा 3 होता है, उसका आधा 1.5. Particle को यहाँ पे आना है. Particle has to move all the way from this point to this point. Am I right? How do we solve it? You can use formulae, x is equal to whatever. I am using some different approach. I'm using an approach which we have learned earlier that says that every SHM is a projection of circular motion. So we have this SHM here. Let us find that circular motion of whose this is a projection. So what I will do is I will draw a circle taking this line as diameter. Okay, let us assume that this is a decent enough circle. Okay, fine. All right. Now, when the SHM particle is here at this point, where is the circular motion particle? जिसका कि ये प्रोजेक्शन है, वो पार्टिकल कहाँ है सर्कुलर मोशन का, जिसका कि ये SHM वाला पार्टिकल प्रोजेक्शन, और वो अभी यहाँ पे है. Right now it is here. Where is the corresponding circular motion particle? वहां पर ही होगा. That's right. Circular motion particle is here only. Am I right? Now, when the SHM particle is here, where does the circular motion particle go? Remember, it's a projection. So you have to draw a projection line. And the circular motion particle will go here. Correct? That means the radius vector traces out an angle which is this much. 90 plus something. Correct? It makes an angle which is 90 plus something. If I know this angle, remember I know T, so I know omega. Correct? Omega is known. Omega is equal to, since it's a uniform circular motion, I can write theta by T. Or delta theta by delta T. Am I right? So what is delta T which I'm interested in? 0.3 by 2 pi into delta theta. Right? So I want to know what is delta theta. Now delta theta is, this angle is 90, which is pi by 2. Correct? What is this angle? How do I find? Correct? How do I find this angle? So I know this side as, see, this angle is same as this angle. Call it alpha. Now this I know, this is 1.5. And this is how much? Radius. Which is 6, right? This is 0. Amplitude is, so you take amplitude and you draw the circle. So this is 6. So if I know this, I can use opposite, sine alpha basically to figure out. Sine alpha is side opposite 1.5 upon 6, which is 1 upon 4, which is 0.25. So that can give me alpha, right? Once I know my alpha, now I leave this here. Once I know my alpha, then my delta theta is pi by 2. Ensure that you find your answer in radians. Plus alpha. Correct? Pi by something. When you place it here, then pi and pi will cancel, and the rest will give you the time. Correct? Yeah. So this is one problem. You people want to note it down, note it down. I'll flash the next problem. So in 10 minutes at least, we can look at the next problem, analyze it at least, and give some enough hints to you people for you people to solve it. Two uniform solid spheres, each with mass m of 0.8 kg and radius 0.0800 meter. So I will simultaneously write the things on the board. So you have two spheres. They're identical in fact. Mass 0.8 kg. The book gives you extra zeros for you people to keep track of significant figures. Radius 0.08, three significant figures, are connected by a short light rod that is along the diameter of each sphere and are at rest on a horizontal tabletop. So उनको बीच में rod डाला है ऐसे. The rod goes through them in fact. So like this. A spring with a force constant K, 160 Newton per meter, has one end attached to the wall and the other end attached to a frictionless ring that passes over the rod at the center of mass of the spheres, which is midway between the center of the two spheres. So you have a center of mass over here, you have a little ring over here to which you connect a spring whose other end is connected to a wall. The spheres are each pulled at the same distance from the wall, stretching the spring and released. There is sufficient friction between the tabletop and the spheres for the sphere to roll out without slipping as they move back and forth on the end of the springs. Show that the motion of the center of the mass of the spheres is simple harmonic and calculate the period. Okay, so now we can look at this. This is our system. These are the two spheres. Okay, this is rod goes through the center. This is top view, remember. Table is there on which it has been kept. You pull it slightly down and release it. It will start moving up as the spring compresses. And then as the spring pushes out, starts moving out. So it keeps moving up and down, starts vibrating. Mathematically, we have to show that vibrations are simple harmonic. Now, to show that the vibrations are simple harmonic, what basic idea we consider? What do we show? You remember? The first premise that the motion is oscillatory or oscillatory motion of simplest type is to show that A is negatively proportional to x. Acceleration in this case will be acceleration of center of mass, which lies here, is proportional to x, which is a distance may be measured from this point. Okay, so this is what we are going to look at. Now the problem says that these two are in perfect rolling. That means as the spheres move, they roll also. Okay, if they are in perfect rolling, we need to figure out what are the forces which are acting. Correct? So if you have a sphere on a table, and this is, let's say, a table, and if you pull it, say, this side, and if you want it to roll, where should the friction work? Static friction. Static friction will work this way. Remember, you pull it this side, it has to roll this way. So static friction will work this way. Okay. If you push it, then the static friction will work this way. So static friction will help the sphere to roll back and forth. What will happen if there is no friction? If the table is frictionless, तब क्या होगा? What will happen if there is no friction? So if there is no friction, it will slip, it will slide. There is no rolling motion. Remember? So now there is a translatory motion of the system. System is going back and forth. So there is a translatory motion of the system. And also spheres are rolling. So there is a rolling motion of the system. System has two kinds of motion over here. Okay. We need to look into both kinds of motion. So first, translatory, and then rotary. So what are the forces acting on the system? Let's look at it. So sphere, this whole thing is a system. Center of mass is here. If it stretches by an amount x, well, r, stretches by an amount x, not the whole distance. The spring will have some equilibrium length here. Say this is equilibrium, and then it stretches by x. Okay. So if it stretches by an x, then the force that will work in the upward direction is kx. Am I right? And as I have established, if the force kx is in one direction, the friction is in the other direction. So you have a friction working on this one, and you have a similar friction. You can take them identical, is working on the other one. Correct? So you have two frictional forces working and one spring force working. So if I take this as the positive side, then the spring force kx has to be equal to, no, minus two frictional forces has to be equal to, in upward direction, mass into linear acceleration. Correct? I'm taking the whole system. This is the total force has to be equal to mass. So this is m and that is m. So 2m into acceleration. Acceleration of what? Sphere or rod? Of what? So this is acceleration of center of mass. We are taking the whole thing as 1. So this is my one equation that I will use. For rotary, what is the situation? So I need to figure out what are the torques working on the system. Torque tau has to be equal to I alpha. So what is torque working on this? Remember, rod is going through the center. So about center point, rod will have 0 torque, or this force will have 0 torque. But these will apply the torque, RF. So there is a torque due to friction, F times R, on this one and on this one. So 2 times F times R. Right? That has to be equal to I alpha. This is my second equation. Okay? Very quickly wrapping up, I'll give you all essential equations so that it then just becomes algebra. How do we get friction? So if the block is kept over here, then mg will work in the downward direction and normal reaction will work in the upward direction. So that friction is coefficient of static friction times mg. So this is my third equation that will come in the picture. Okay? But we need one more equation because these are disjoint equations still. There are two unknowns. So here F is unknown, A is unknown. Here F is unknown, alpha is unknown. So we have three unknowns and two equations. So I need, because this will not give me any information. This is an equation for F, but then mu is unknown, I guess, in the problem. So we need one more equation to deal with. Okay, what is that equation? The third equation that we need, it comes from the fact that this is a perfect rolling. Okay, what happens in perfect rolling? Perfect rolling situation. Perfect rolling is equal, for perfect rolling to happen, you have V is, no, sorry, A linear acceleration has to be equal to R into alpha, tangential acceleration. Correct? So this is the equation that will relate this and this. So you can eliminate one of them and solve everything in terms of X and ACM and see if you can prove this. Right? Remember that if A is equal to minus kx, then we know that omega is 2 pi by 2 pi t, which is root 2 pi upon t. What is the time? 2 pi upon t, and t is what? Root, t is root k by m, right? Larger the mass, lesser the time period. So this will become root m by k. This is a general equation. Once you prove this, you can identify k, whatever are the coefficients, and then use it here to determine omega. Correct? Which will eventually, question is asked that what is the time period, which will eventually give you the time period. Okay. So anyways, I think I had only two problems on the plate, and then I thought that I will talk and discuss a few more extra things, which unfortunately nothing couldn't happen. We'll talk in the next class or in the lab time today. We can talk. So thank you. You can stop live streaming.